Question 10 has a triangle of base length 2 units and perpendicular height 8. We can see over here. The diagrams T1, T2 and T3, the first three shapes in a sequence of shapes based on this triangle. So we seem to have a triangle inside one rectangle, and then the same rectangle but broken up into triangles. Now we have 4 triangles here. We have 6 in this one. Okay, we have the consistency of the triangle inside. Draw T4, so divide it up into 4 equal heights. 1, 2, they're all too wide, you can see here. So stage 4 is with the rectangles. So complete rectangle. Nice and easy part to start. Show that the total area of the 3 rectangles in term 3. So 3 rectangles of equal height. So show that the area of the 3 rectangles. So in here, we're just looking in here. So we have a 2 down the bottom. So the first rectangle is going to be this one here, number 1. The height is going to be the 8 divided by, it's divided in 3. So 2 by 8 over 3 is the first rectangle, number 1. 16 over 3. Number 2, we need to know what these sides are. There's 6 of them, we can see here. 1, 2, 3 on each side, and it's 2 wide, so it's 1 wide on each side, so each one of them is a third. And we have 6 of them overall, which would make the 2 at the bottom. So we have 8 over 3 by 1 over 3. No, 8 over 3 by the width, which is 2, take away the 2 1 over 3s. It's 2 take away 2 over 3, which is 4 over 3. And that's going to be equal to 32 over 9. And then number 3. We have just the width by the height again, so it's going to be 8 over 3, and we'd have to take away 4 of the triangles, so it'd be 2 minus 4 of the widths, so that's going to be 2 over 3, which is 16 over 9. So what's this, 48 over 9, which dividing both by 3 we get 16 over 3. And the first one was 16 over 3, so 16 over 3 plus 16 over 3 is 32 over 3. Square units, units squared. Part C is the total area in terms of n, and n is a natural number. Give your answer in units, square units in terms of n, so the total area of the shapes. So let's have a look at these. I think there's a pattern going on here. We've got the 8 consistent in the middle in all of them. So we also have 2 triangles here. The width here is 1. Just put it on here. The height is 8. So these are changing. These heights and widths are what's changing. The 8 stays consistent. So we need to look at what's happening here with the widths. The widths are a height of 8, or the heights, let's say the height, we'll call this one. The height of them is the 8 divided by the stage that they're in. This one is 8 over 2, stage 2. These will be 8 over 3 in stage 3, so the heights of them are 8 over n. We call this the width of them. In this case we have 4 of them. So we have 4 triangles. The width of them is 2 over 4, which is 1 over 2. The width of these guys, there's 6 of them. So it's going to be, we visualize 3 on each side. Each of them will be 1 divided by 3. There's 2 on each side here, 1 divided by 2. So the width is 1 over n. We have the height is 8 over n. So we have a format here. How many triangles have we got? We've 2 here. We've 4 here. 6 here, so that's 2n, 2 by 1, 2 by 2, 2 by 3. So we have, in every shape, we have 2n triangles, and the area of every triangle is half. We call the base the height here. The base 8 over n by the height, which is w, that we got 1 over n. So that looks like what we have here. We have 2 triangles in the first one, so there's actually a 2n on both top and bottom, so we just end up with 8 over n here for the area of the triangles. So we'd have to add 8 to that. So does that work for pattern 3, where we were told 3 of them added up to 32 over 3? So this will be 8 plus 8n. 8 plus 8n. It looks like what we have. We have the triangle in the middle and then the pattern on the outside. In sequence 3, there would 8 times 3. Sorry, 8 over n. I'm writing in the wrong place. So that's 24 over 3. 8 plus 8 over 3, which is 32 over 3. So that looks like our pattern here. 8 plus 8 over n. 8 plus 8 over n. Part D, we have the total area of rectangles in a different sequence is given by this. Work out the first value for n for which this is greater than 95%, greater than 95% of the area of the triangle. Half the base by the height. This is the same triangle, it's 8 units, 8 units squared. So 0.95 by 8 is 0.76, so it has to be this 8 to the end is 8n minus 8 divided by n has to be greater than 0.76. So 8n minus 8 greater than 0.76n. Bringing the 0.76n to the left, we'll get 0.04 left, 7680. That will be greater than 8, little n there, so 8 divided by 0.04, and will have to be greater than this, and 8 divided by 0.004, just working back with a calculator and checking, it's 7.6, be careful. So 7.6n does make a difference, obviously. We're going to get 0.4n, not 0.04, greater than 8, and greater than 8 over 0.4. I got this by checking my answer. So n would be greater than 20. So n would be equal to 21. Just be careful if you're going to not use a calc. Last part of this question, diagram A shows a square base pyramid with sides of C. You can see that here. And diagram B shows the same pyramid, same base. And it has X moving down, it seems. And inside here we have a shaded diagram B. The area of the shaded diagram is this guy. So the area of this square in here, they call it a square. Horizontal square it is. Okay. So what's happening here? The volume of the pyramid is the integral of the area. Well, we know that. Volume, if you integrate area, we get volume. So we're integrating between h and 0. This guy, x squared, is what we're doing it with respect to. The c squared over h squared will be seen as a constant, dx. So integrating, increase the power by 1 and divide by the new power. The constant will stay the same. And if we do all of this between the bands h and 0, 0 will give me a 0 value, so it's just h. So we're going to have h cubed over 3 times c squared over h squared. So we get h c squared over 3 for the volume in terms of c and h. We could write c squared h as well. That's part 1. Part 2. Part 2, x starts to increase at a rate at 3 units per second. X is increasing, so the rate of change of x with respect to time is equal to 3 units per second. This causes s of x to increase as well. Find the rate of change of s of x. So s of x is area. So we want the rate of change of area is dA dt. At an instant when x is half the perpendicular height, so it looks like x at some point is half of h, which was the height. So we're looking for the a dt. That's going to be equal to dx dt. Set up our chain rule. And we'd have to get dA on top. We have the dt in the bottom, so we're looking for dA dx here. So we have area. Let's just remind ourselves, area is x squared ch c squared x squared. Area is equal to x squared times c squared over h squared. So dA dx is equal to, well, the 2 will go in front, multiplied by the 1, so it's just 2x by the constant c squared over h squared. That's dA dx. We know dx dt here. Dx dt is equal to 3, it's given in the question. So if we multiply this by 3 by dx dt, that will give us dA dt. So we're going to get 2x, actually it's going to give the 2 by the 3, it's going to get 6x times c squared over h squared. We're told that x is equal to h over 2. X is equal to h over 2. So we're going to get 6 times h over 2 times c squared over h squared. So it looks like the answer is going to be 2 into 6 goes 3 times. H will cancel with the squared, so we're going to get 3c squared over h, and that's in units per second in terms of c and h. Just to finish that off, 3c squared over h.